Alright, students, this video is going to be going over 2.6 for Math 3. This is mostly about parabolas, and there's a couple different things we're going to do with parabolas. So first, the book goes over a general diagram, and it throws an equation at you that's pretty high level. This is what we're going to know as vertex form. Don't worry about that too much, we'll clarify. Over here, you have what's known as standard form, and we'll talk about that as well. The main thing about standard form, you have three variables, and they use A, B, and C. We use different variables for the vertex form, as we'll see. Before we get into that, though, I do want to show you why this stuff is useful. So if we go over here to, we're over at mathisfun.com, and right here on this lesson on parabolas, they show a athlete kicking a soccer ball. And what you have is, you have the general equation here. Don't worry about the values of the variables. We'll talk about that. Okay? But the idea is that each one of these affects it in some way. Okay? Now, you'll notice it's moving left to right, but it's also changing height. So, it's sort of a left-right movement, but it's also up-down. This one is changing sort of the shape of the palm, and then A flips it upside down or right side up. Okay, so it's a little bit different from what we did before, but the idea is pretty much the same. This is exactly what was going on behind the game Angry Birds. That was Angry Birds Physics Edition. This is way more than it really is. The main thing with Angry Birds was it was a parabola. So essentially, it was one equation, and it was just like this. Very much like this, but instead of having sliders like this, you dragged your finger to control the angle and the amount of pullback of the slingshot. And here's a more basic version of it. The whole thing, like I said, at different angles, you go different distances. So behind the scenes in Angry Birds, there really was just one equation running. This equation right here, but the user had control over the numbers. Okay, you didn't type the numbers in. It was more gamified, so you'd actually have some fun with it. But the whole idea was when you were dragging the slingshot, pulling the slingshot back, you were affecting these numbers, okay? And that's the idea. And we'll learn how to convert these from either form, when it's vertex form, to standard form, to intercept form. So let's get to that right now. Okay, so go ahead and write this in your notebook, please, students. There are three forms for parabolas. I'm going to lay them out right here. First is, we'll start with standard form. And it looks like that. Okay, standard form's one of the cleaner ways to write it, but you can't tell a lot of information. For example, you can't tell where the intercepts are or the vertex. We'll look at those next. Intercept form looks a little different. We still have the A variable, but your rest of the equation is written in what we call factored form. So if you remember factoring, that's how you get from one form to the other. And finally will be intercept form. And there is our vertex form. So you're going to want to have all of these sort of organized on one sheet. They're all, of course, in the book, but they're on different pages and things like that. We're going to try and organize this so we can discuss all of them. Okay. So let's start with we'll start in the middle. Is actually X-Intercepts here will be X equals P and also X equals Q. Oh, I'm sorry, you can't see that. There we go. X equals P and X equals Q. And that's because when you solve this equation by setting it to 0, you'll get those. And we'll go through an example like that. In this form, the key information is this. And we've done this before. We knew that with the standard parabola, it was x squared, but subtracting h inside was a horizontal shift. And the k gave us a vertical shift. So in this form, we know the vertex. We know h and k, which is different from this one. We know two intercepts. Okay. In standard form, we don't know either of those. But there's a method that tells us that the line of symmetry is given by x equals negative b over 2a. Again, we'll talk about why these things are, but in a separate video. So for now, you have the three forms, and let's draw a quick picture that will help illustrate that. So I got an x and y axis drawn quickly here. What it is, if you take a look at that shape, got two key points here. Let's go and move that down. These are the intercepts. Okay, those are the X-Intercepts. Okay, and these are important for different reasons, but over here I'll just draw a quick, if you remember a person kicking the soccer ball, make a ball there. When they kick the soccer ball, it's a very poorly drawn ball, I apologize. The intercepts would be, if this is the ground, the intercepts where it started and where it finished. And the vertex, for the soccer ball, the vertex would be the high point. So a lot of times, those are the key things we're interested in. Where did it start? Where did it stop? And where was the maximum or where was the minimum? So for this one, it's a maximum, because it's at the top. But if you have a parabola looking like this would be the low point or the minimum. Oops, that's off the screen. There we go. Okay, final things here is the line of symmetry. Now again, the line of symmetry goes right down the middle and through the vertex. Okay, and if I drew this perfectly on graph paper, when I fold that line of symmetry, my left half and my right half should match up perfectly. So if I could fold it right on that line of symmetry, if you had tracing paper, we would do that. If we were in class, I would have tracing paper. I'd hand that all out for you guys, and we'd do that. What we're going to do is more sort of see it on Desmos and see that as you go up, for any point on this side, there's an identical point on that side. It's symmetric. We get the same distance there. The left side should look exactly like the right side. Okay, and that makes it easier for graphing, because if you graph this point, you know it has an identical point there. Graph this point, you know there's one there. And all these little tricks are going to make graphing a little bit easier. Okay, so again, there's 3 forms, wrapping this up, there's 3 forms. You'll sort of want to be able to go comfortably between all of them. Some things are easier. I'll be honest with you. I sort of prefer if it's in intercept form. Okay, because if it's in intercept form, I can find those 2, and there's a way to get to the vertex. If it's a standard form, there's a rule for the line of symmetry, and the line of symmetry contains the vertex, so there's a way there also. All of these can be used. So if you're given any one of these, you can find all the key information. It's just there'll be a different method. So we'll make a short separate video for these going through numbers, because you'll notice if you get overwhelmed by the fact that there's no numbers here, that's totally normal. This is tough stuff. We're getting into where we really read a textbook form, so that A, B, and C are just numbers, and when we have values, we'll plug them in and we'll run it through. But we'll save that for the next video. Thanks for watching.